All right, this is a mini lesson on chapter 10, circles. If you want to read the main points, you can pause this now, read them. But just as it was true with the other mini lessons, the number of problems here are taken from the review packet, but the numbers were changed. Not all the questions that we're going to do right now are actually from the packet, so you might just want to sit back and listen and take some notes. All right, these are like questions 36 and 37 in your review packet. This is a concept that deals with one main fact, and that is the fact that two tangent segments from the same external point are congruent. When you see this fact, this setup is very simple, okay? X squared minus 10 equals 2x squared minus 26. So you solve this by subtracting x squared and then adding 26 to both sides. These cancel, you're gonna get 16 equals x squared, square root, x equals plus or minus 4. Both answers are going to be legitimate because if you plug in positive or negative 4, when you square those numbers, you're going to get a positive number both times. The last question is, what is AP? Well, AP is the segment here, which has a length x squared minus 10. So when you plug in 4, let's cross that out. I got 4 squared minus 10 is going to be 16 minus 10. Or negative 4 squared, you're going to get the same thing. It's going to give you 6. So I see that AP is actually going to be 6 as x was positive or negative 4. The next problem is a chord with the distance drawn to the chord and the radius drawn to where the chord intersects the circle. So basically, one thing to remember is that the radius, chord, and distance form a right triangle. Okay, this is what I'm talking about. The radius here, the chord, half the chord, and the distance form a right triangle, okay? The other main point is that a line from the center of a circle that's perpendicular to a chord bisects that chord. So that's this line right here. That cuts this chord in half. And that's a main property that you're going to use to find the length of the entire chord, because what I'm concerned with is how long is this chord. Well, it tells us that the chord is 8 centimeters from the center, so that's the distance. And then the radius is 10. So if you've seen this triple enough times to realize that this is going to be 6. If you wanted to, you could call it x and do your Pythagorean theorem. But hopefully by now you could tell that that's going to be 6. Well, if that's 6, so is the other part, which makes the entire chord, which is what I wanted to find, 12. That was number 84. Problem like number 85 is a walk-around problem, okay? Two tangents from the same external point are congruent. And that's the same idea that we used in 2 problems ago, okay? And we're going to use that same concept for this particular question, okay? So two tangents from the same external point are congruent. So then once I figure that out, I walk around the picture. All right, what I do to start is I label all these sides. AB is 16, BC is 20, CD is 12, and I'm concerned with how long is AD. So this is a walk around question, and it really does not matter where you start. Wherever I start, I call it X, okay? I'm going to start there. Again, it does not matter if you want to try to start somewhere else and see if you get the same answer. That would be a good exercise, okay? So after I find the answer, you could pause it and do that. But if this is X, because two tangents from the same external point are congruent, SC being X makes TC X. And now if SC is X, BS is 20 minus X, and then RB or BR is also going to be 20 minus X. I'm going to stop there because I get to a certain point, and then I'm going to look at DT. Well, DT is 12 minus X, and so would DV be. So I'm just kind of walking around. So then if TC is X, DT is 12 minus X, I'll walk around there. I can't go any further here. I can't find AV right now because I don't know how long AD is. But I can find AR, and this is where a lot of you guys make your mistakes. So AR is actually equal to 16 minus the quantity 20 minus X. Okay, not minus 20 minus X, it's just all together. So when I do this, I got to make sure I distribute the negative. So 16 minus 20 is negative 4 plus X. If I want to switch that around so that I don't have a negative leading out front, I get X minus 4. So I see that AR is X minus 4, which makes AV X minus 4, which makes the part that I'm looking for X minus 4 plus 12 minus X. And if you do this correctly, you'll see that the X's will cancel because you'll get a positive and a negative X. Negative 4 plus 12 gives you AD as 8. If you want to start somewhere else and try it again, feel free and see if you will also get AD to be 8. All right, now we're going to talk about some of the concepts from later in the chapter, which is angles inside a circle. So angles with a vertex at inside the circle have a certain formula, okay? I sometimes say 2 times the angle equals x plus y. Actually, this is how I teach it to my students. If your teacher is a little bit different, they might say the angle is equal to half x plus y, or angle equals x plus y divided by 2. However you remember it, the angle is basically an average of x and y, is what you're going to come up with. That's if the angle's not at the center. If the angle's at the center, the angle equals the arc. It's very simple. Okay? That's if the angle's inside. It could either be not at the center or at the center. If it's not at the center, you get this formula. If it is at the center, you get angle 1 equals x. Outside the circle, it's a little bit different. I teach my students 2 times the angle is equal to big arc minus the small arc. Okay, so now you subtract instead of adding, like you did when it was inside, you added. Now it's outside, I subtract. Or you can say angle 1 equals half big arc minus small arc. Either way is going to get you the same answer. And in fact, that formula is going to work the exact same way for this problem as well. Okay? Just because that is a tangent line doesn't make it any difference. You're still going to get the exact same formula, and recognize the difference. Okay? Angle inside, vertex is inside, I add. Okay? Vertex is outside, like it is here and here, I subtract. Okay? Very simple. The last way that you got to think about angles relating to circles is if the angle's vertex is actually on the circle. What I mean by that is the angle's vertex lands and touches the circle. And this happens in 2 ways usually. It can either be inscribed, and in both circumstances, the angle is equal to half the arc. Or if you thought about it the way I was showing it before, I could say 2 times the angle is equal to the arc. Either way will get you either the angle or the arc, depending upon whatever you're looking for. But basically what it comes down to is that the arc, here is always going to be twice as big as the angle. And that's the relationship there. Now that you've kind of refreshed your memory over these formulas, you could try to attempt 42 through 46 in your packet. See if you can do those problems. The answers, again, are in the back of your review packet. There are also relationships between segments and circles and figuring out the lengths of segments. Okay, if segments cross inside a circle like they do in this first picture, you get BA times AD equals CA times AE. I don't need to sit here and explain all these. These formulas are basically a review. What I did want to explain was the segments outside a circle. And the segments outside a circle, you got a part outside, and you got a whole segment. Okay? And then you got a part outside a second segment, and then you got a whole segment. So when I set these problems up, I always think in my head. I say part outside times the whole. So in this particular case, I'm going to say CA times the whole equals CB, part outside the second segment, times the whole second segment. Okay? And that's how I get CA over CE equals CB over CD. And that's how you set this up. So again, CA over CE equals CB over CD. And you can set the other problem up in a similar fashion. Even though the part outside, and what happens with this is the part outside and the whole actually are the same segment. So when you do that, you multiply the same thing times itself. Like you do here, you're going to get that number squared, which is why I got AB squared equals the part outside AD times the whole AC. So that's where I got AD times AC. So that's the setup here. So here is a problem that uses this idea. And again, there's some important points to remember, but for this particular question, it's simply just part outside times the whole. Well, in this case, the whole is x plus 1. In this particular case, it's 2 times the whole 6. So when I do this, I cross-multiply, distribute x squared plus x equals 12. Bring the 12 over, I get x squared plus x minus 12 equals 0. X plus 4, x minus 3. And I got those numbers by figuring out what multiplies to negative 12 but adds to 1. And I figure, well, 4 and 3, but it's going to be negative 3 and positive 4 are going to multiply to negative 12 but still add to positive 1. So therefore my answers for x are negative 4 and 3 But negative 4 doesn't work, because if negative 4 was plugged in here, I would get a negative segment, and that makes absolutely no sense. So your answer to this one is actually just x has to be 3, and that's actually your final answer to that question. All right, last idea is the equation of a circle. Okay, here's the standard form of the equation of a circle. If you want to pause and refresh your memory, look at that. I got a question. What is the equation of a circle with center at 4, negative 5, and radius 2? If you want to pause and try to think about it, pause right now. But the answer is x minus 4 squared plus y plus 5 squared. And simply, what you do is you take the opposite of the center. If the center is 4, negative 5, I put in x minus 4, y plus 5. And if the radius is 2, I simply just square that and plug that in on the right side. It's a very simple equation. Going backwards, I could pull the center and radius out of there in a similar fashion. And I hope this was helpful. If you have any questions that you didn't understand, you can either rewind and pause, or you can ask your teacher.